everybody, welcome to the chemistry channel. So today we are going to be starting lecture 7, and lecture 7 is going to be dealing with balancing equations. So we're going to be talking about the balancing of chemical equations. So this is a very fundamental skill in chemistry. A lot of chemistry that you're going to do relies on this skill, and this is actually arguably where the true chemistry begins in general chemistry. So this is going to be a relatively short video. We're going to only introduce a couple of concepts here, and then we're just going to go through one practice problem together, and then we'll have some 2 practice problems at the end. Okay? So let's begin. So what is a chemical equation? Well, a chemical equation is basically a way in which we represent a chemical reaction. So it's a way in which we represent a chemical reaction. So let's put on here a generic chemical reaction. So here I have R, and on this side I have P. The R represents reactants, and that's because reactants are often found on the left side of the equation. P stands for products. Products are found on the right side of the equation. So that's why I have the R here and the P here. And there's only 2 laws that you need to know for balancing equations. The first is called the law of conservation of mass, the law of conservation of mass. And this states that atoms are neither created nor destroyed in a chemical reaction. So in other words, the mass, the total mass on the reactant side of the equation must equal the mass, the total mass, on the product side. So mass must not be created nor destroyed. So this is the law that we are going to be dealing with in this video. The second law will be primarily dealt with in Gen Chem 2 when we get into something called redox reactions and electrochemistry. So this law is called the law of conservation of charge. So this means charge. And we're not going to really get into this in this video. This is going to be something that we tackle with in Gen Chem 2. It's actually way more complicated than, to balance these types of equations than it is to balance the equations we're going to do in this video. So this is going to be saved for Gen Chem 2. However, it's good to know the concept. And the law of conservation of charge states that charge cannot be created nor destroyed. So it's the same idea. So we're not going to get into this idea of conservation of charge yet. We're only going to deal with this first law. So let's start by talking about a fundamental reaction. And I'm going to go through the process that I use in order to solve these types of problems. So we're going to start off with a very simple reaction. So the first thing that I want to do is, you should not do this on an exam, but the first thing that I want to do is add up the masses. Now, you should not add up the masses on an exam. It would take up too much time. This is just to show you that the masses in this equation are not equal on both sides. So this is just to show the action of the law of conservation of mass in action. So let's try this. And this is also going to show you the importance of balancing equations properly. So this equation is not balanced, and we can prove this by adding up the masses on both sides. So we have 2 H's on this side and 2 O's. We have 2 H's on the product side and 1 oxygen. So we can just, from this we can already tell that the masses aren't going to be equal, but let's just show it mathematically. So 1 hydrogen weighs 1 AMU, so 2 times 1 AMU, plus 2 oxygens, which weighs 16 AMU. Therefore, the total mass on this side would equal 34 atomic mass units. On this side, we have 2 hydrogen and 1 oxygen, therefore 2 times 1 atomic mass unit plus 1 times 16 atomic mass units would equal 18 atomic mass units. So these two sides are definitely not equal in mass. So therefore, we have to balance the equation. So let's revert back to this little chart here. I like to make these charts for every single balancing problem. So you have a reactant side and a product side, and you list the reactants and products underneath each segment. So here we have the 2 hydrogens and the 2 oxygens, and here we have the 2 hydrogens and the 1 oxygen. So from this little table here, we can tell that we need to add 1 oxygen on the product side. And the only way we can do that is multiplying the water by 2. So let's do that. So if we multiply the water by 2, we get H2 plus O2 goes to 2H2O. And now if we put down the amounts of elements on each side, we get 2 H's and 2 O's on the reactant side, and 4 H's and 2 O's on the product side. So therefore, we now see that the hydrogens are not balanced. So now what we got to do is add 2 hydrogens to the reactant side. And the only way we can do that is to multiply the hydrogens by 2. So the H2 by 2. So therefore, our next equation would be 2H2, not 4. Okay, so 2H2 plus O2 to 2H2O. So now let's see if this equation is balanced. So let's draw our little table. So we have 4 hydrogens on the reactant side, 2 oxygens on the reactant side. We have 4 hydrogens on the product side, and 2 oxygens on the product side. So this is the balanced equation. And this general process that I just showed you can be applied to any of these balancing problems. So believe it or not, that's it for today. And what I want to do now is just go do some practice questions. Actually, I have one more concept to show after these practice questions. It's very, 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 very short. So the practice questions that I have for you is, I want you to balance these 2 equations. I don't want to circle. Okay. So CH4 plus O2 goes to CO2 and H2O. I want you to balance this one. And I also want you to balance C4H10. So let's just fix this 4. C4H10 plus O2 goes to CO2 and H2O. So I want you to pause the video and try to balance these equations. So hopefully you pause the video to balance these equations. So let's do this together. So once again, let's start with our little table. So on our reactant side, we have 1 carbon, 4 hydrogens, and 2 oxygens. And on our product side, we have 1 carbon, 2 oxygens, and 2 hydrogens. Actually, we have 3 oxygens. I forgot the one on the water. So let's write 3 oxygens, okay? So the first thing that I want to do is balance these 2 little hydrogens here. So the way we do that is we have to add 2 hydrogens. So therefore, let's write our new equation. We get CH4 plus O2 goes to CO2 and 2H2O. So now let's write our new little table. So we have 1 carbon, 4 hydrogen, and 2 oxygen. And we now have 1 carbon on the product side. We have 4 oxygen and then 4 hydrogen. So now we need to add 2 oxygen on the reactant side. And the only way that we can do that is multiply this O2 by 2. So when we do that, we get CH4 plus 2O2 goes to CO2 and 2H2O. So now let's see if this is balanced. So reactants, products, we get 1 carbon on the reactant side, 4 hydrogens, and 4 oxygens. Next we get 1 carbon on the product side, 4 oxygens from the 2 O's on the CO2 and the 2 O's on the water, and then 4 hydrogens. So therefore we see that this equation is balanced. So this is your answer. So let's go on to the second one here. So let's create our reactants and products table. So we have 4 carbons on the reactant side, 10 hydrogens, and 2 oxygens. And on this side, we have 1 carbon, 3 oxygens, and then 2 hydrogens. So the first thing that I want to do is I want to balance the hydrogens. So the first thing that I want to do is multiply the H2O by 5. So we have to add 8 hydrogens on this side in order to balance the hydrogens. So we multiply the H2O by 5, and this would give us C4H10 plus O2 goes to CO2 and 5H2O. So now let's write our new reactants and products table. So we have 4 carbons, 10 hydrogens, and 2 oxygens. And then on our product side, we have 1 carbon, we have 7 oxygens because we have 5 oxygens from the H2O and 2 oxygens from the CO2. And then we have 10 hydrogens. So now what I want to do is balance the carbons. So we have to increase the number of carbons by 3. And in order to do that, we have to multiply the CO2 by 4. So therefore, let's write our new equation. So C4H10 plus O2 goes to 4 CO2 plus 5H2O. Okay, so now let's write our reactants and products table. So our reactants and products, we have 4 carbons, 10 hydrogens, and 2 oxygens. Here we have 4 carbons, 10 hydrogens, and we have 8 oxygens from the CO2 and 5 from the O. Therefore, we get 9 oxygens. So 8, no, that's not right. That's not math. So let's do the correct math. So we have 8 from the CO2 and 5 from the water. So therefore 8 plus 5 equals 13 oxygens. So 8 and then 5, so 13 oxygens. So now what do? How do we get 13 oxygens on this side? Well, you can actually multiply this by 7.5. So C4H10 plus 6.5, not 7.5, plus 6.5 O2 plus 4. Let's actually put the arrow there. That's a mistake. So arrow. So C4H10 plus 6.5 O2 goes to 4 CO2 and 5 H2O. Now we can't have a decimal point here, so the thing that we can do now is multiply the whole equation by 2 in order to get whole number integers. So therefore we get 2 C4H10 plus 13 O2 goes to 8 CO2 plus 10 H2O. So now let's see if we have balanced reactants and products. So we have 8 carbons, right? And then we have 20 hydrogens. That's a lot of hydrogens. So 20 hydrogens. And then we have 26 oxygens. So 13 times 2 is 26. So on the product side, we have 8 carbons. And then let's do the hydrogens. We have 20 hydrogens. And then we have 16 oxygens plus 10 oxygens, which is 26 oxygens, because 16 plus 10 equals 26. So this is your balanced equation. So this is probably one that your professor would probably give you on an exam. So let's just double check. 8 carbons on this side and 8 carbons on this side. 20 hydrogens on this side and 20 hydrogens on this side. We have 26 oxygens here, and then we have 16 plus 10, which is 26 oxygens here. So therefore, this equation is balanced. So that was a more difficult one, but that's probably more representative of what you'll get on a college exam. All right, so one last topic for today. It's going to take 2 seconds. So the first, I want to talk about states. So it's important to indicate the states of the reactants and products. So therefore, as subscripts, so these are subscripts, we indicate the state of the reactant or the product and the products. So L is for liquid. So if your reactant or product is a liquid, so for example, if you had H2O in your chemical equation, you'd put a little subscript of L. You can also put G for gas, in which case if you had a water vapor, you would put a little subscript G there. You can also put S for solid. So if you had ice, you would put a little subscript S. And then lastly, if you had something dissolved in water, you put AQ, which means aqueous. Okay, and this means something is dissolved in water. So an example would be Na plus, and then you'd put AQ here. So that is it for today, guys. So that's the first step into becoming a true general chemist. So in the next video, we're going to be talking about the different types of chemical reactions that exist in the universe. So we're going to be talking about combustion reactions, neutralization reactions, decompositions, combinations, etc. So it's going to be a cool video. And I hope this video helped you, and I hope to see you next time. See you around, guys.